Hi everyone, welcome to Module 5. Those papers are really starting to take shape. Keep up the great work, and as always, feel free to contact me if you have any questions. I like the way you're using the APA format and the topics you're selecting, and look forward to reading future versions of your paper. This week, we cover some of the basics of inferential statistics. Okay, so you have gathered some data, and now you want to communicate that to other people. What information are you going to share? As an aside, if you had to guess the score of a test, any test, what would be your best guess of any one person in the class, county, or state on that test? It would be the mean. So what important information do you want to share with others about your research? So we will take a look at measures of central tendency, variability, and correlation. Just because you found a study is significant, how large is the effect? It might be important to communicate with other doctors how big an effect a medication had, or to educators how large an impact a given intervention worked with fifth graders. So let's dive into it. Statistics is a branch of mathematics that involves the collection, analysis, and interpretation of data. The two main branches of statistics assist your decisions in different ways. The two main branches of statistics are descriptive statistics and inferential statistics. We use descriptive statistics when we want to summarize a set of numbers in order to communicate their essential characteristics. One of these essential characteristics is a measure of the typical or representative score, called a measure of central tendency. A second essential characteristic that we need to know about a distribution is how much variability or spread exists in the scores. The measures of central tendency are the mode, median, and mean. The mode is the score in a distribution that occurs most often. The median is the number that divides a distribution in half. The mean is the arithmetic average of a set of numbers. The mean is found by adding all the scores in a set and then dividing by the number of scores. A researcher can graph his or her results using a number of different ways: a pie chart, a histogram, a bar graph, frequency polygon, or a line graph. You can find statistical formulas in Appendix B of your text if you are interested in reviewing or specifically learning how to calculate different statistics. All statistical formulas merely require addition, subtraction, multiplication, division, and finding square roots. Many psychology departments have access to some standard statistical packages such as SPSS, SAS, BMD, Minitab, and others. You can also find a number of different statistics in Excel. There are several measures of variability: the range, variance, and standard deviation. The standard deviation is the square root of the variance. It has important relations to the normal curve. The Pearson product moment correlation coefficient is calculated when both the x variable and the y variable are interval or ratio scale measurements and the data appear to be linear. Other correlation coefficients can be calculated when one or both of the variables are not interval or ratio scale measurements, or when the data do not fall in a straight line. Inferential statistics is used when you are trying to make a decision about your data. You are typically trying to decide, is one group statistically different from another group? The null hypothesis is a hypothesis that says that all differences between groups are due to chance. That is, not the operation of the independent variable. If a result occurs often by chance, we say that it is not significant and conclude that the independent variable did not affect the dependent variable. If the result of our inferential statistical test occurs rarely by chance, that is, it is significant, then we conclude that some factor other than chance is operative. There are two types of error that can occur in an experiment: type 1 and type 2 error. The experimenter directly controls the probability of making a type 1 error, or by setting the significance level. You are less likely to make a type 1 error with a significance level of 0.01 than with a significance level of 0.05. However, the more extreme or critical you make the significance level to avoid a type 1 error, the more likely you are to make a type 2 error. Type 2 error involves rejecting a true experimental hypothesis. Type 2 errors are not under the direct control of the experimenter. We can indirectly cut down on type 2 errors by implementing techniques that will cause our groups to differ as much as possible. For example, the use of a strong independent variable in large groups of participants helps reduce type 2 error. The effect size is the magnitude of the size of the experimental treatment. A significant statistical test tells us only that the independent variable had an effect. It does not tell us about the size of this significant effect. Cohen's d tells us the magnitude or size of the experimental treatment. Cohen in 1977 indicated that d values greater than 0.8 reflect large effect sizes. Okay, well that wraps up Module 5. Have a great week. Keep working on those papers. Hope you all had a fantastic Memorial Day, and that it was sunny for you, and you got to spend some time out in the sun and the surf. Have a great week, and as always, we'll see you around campus. Take care.